Well, thank you all for staying here. Along with Amy down there at the end, I was working with Greg and Brad and a few others to try and help organize the meeting. And we got into some discussion early on about what kind of events could we schedule in here that would be exciting and engaging for the crowd. And we remember back to 2009, back when we were called the NASA Lunar Science Institute, we had a panel that year that included a handful of folks from the Apollo missions. And I particularly remembered Gordon Swan, Lee Silver, and Gary Lofgren joined the group. I had only been at Goddard for a few years at that point, and that panel was very inspiring to me, hearing these folks talk about what the mission, especially the training that led up to the successful missions, meant to them and how involved they were with it. And it really got me excited and actually led me to start talking more to Dean Eppler, who's on the panel here, about how to get more involved in some of this work. And I think some of the talks earlier today pointed to some of the exciting things that are going on in preparation for hopefully landing humans somewhere here in the not too distant future. So we organized this panel today. So we're I just said to Jack, we're on an anniversary that ends in 5, so that's an important anniversary. It's 45 years for Apollo 17.
And we may not have 5-0.
Well, let's not say that. We will have 5-0, but this is still 45, so we're going to celebrate it. So the purpose of the panel today was very similar to the inspiration that the panel in 2009 gave to myself and others in the audience. We just want to have a chance to hear from some folks involved in Apollo 17 and Apollo in general, and then how that has shaped careers on through the years. And we also are dedicating this panel to Jack's crewmates, to Ron and to Eugene. So in celebration of Apollo 17, dedicated to Ron and to Eugene. At the end of the table here, we have Amy Fagan, and she's on this panel for a specific reason. I wanted to have someone more in the early career phase that can talk a little bit about how Apollo may have influenced her choices and where she is in her career right now. Dean Eppler.
Well, she doesn't have gray hair.
She does not have gray hair. That's accurate. So Dean Eppler.
Late careers down here at this end.
So Dean Eppler sitting beside her, and he's on the panel because of one picture that we'll show. We'll put up a slideshow here in a few minutes. Picture of him involved in opening the last sample container that came back from Apollo 17. And so he was just starting his career at the end of Apollo 17, and it had an influence on him as well. Dean also supported our next-gen efforts. So with the Lunar Science Institute early on, we had a next-gen effort intended to try and engage the next generation of students with folks who have been in the field. And Dean has supported that, and he gave one of the more interesting comments I've seen at one of these one time. You always see people say things about, doing well in school and being inspired and asking questions. And Dean said, stay fit, because sometimes you're going to be up late at night, and sometimes the people you're supporting are up late at night, and you need to be there to support them. And being healthy makes that a little bit easier. So then we also have Jim Head, and he has been involved in training for Apollo 17 and Apollo in general. And he's helped us in preparing to train all the astronauts basically since then. And he's been very involved and inspiring for the rest of us who have been trying to carry that torch forward as we move on. And then, of course, we have Jack Schmitt, who was on Apollo 17 and actually walked on the surface of the moon. So I don't want to spend any more time really getting into it. What I would like to do is give each of them a handful of minutes here. I told them 8 in an email, so I'll try to keep them wrangled into the 8-ish time frame. But the real purpose is to have some questions from the audience and really give folks in the crowd a chance to ask some questions of the folks on the panel. So I also want to introduce Cindy Evans from JSC. So she and I are working together on a number of things related to science and support for human spaceflight. And together we'll moderate the panel as we go forward. All right, so with that, Amy, go ahead, please.
Thank you, Jake. So again, I'm Amy Fagan. I'm an assistant professor at Western Carolina University. It's about an hour west of Asheville. And yes, you can still be in North Carolina and be an hour west of Asheville. I'm starting my 4th year teaching. I'm a petrologist, but I also teach an astronomy class called the Solar System. So, oh, pictures. For me, some of the importance of Apollo, I wouldn't be here, first of all, if it weren't for Apollo. About half of my PhD was looking at Apollo samples. So I began graduate school, and this is also a little plug for the younger people. The way you start graduate school is not necessarily the way you're going to end it. I was in love with Mars, and I was going to do Mars geomorphology. And after almost 3 years of graduate school, it became necessary for me to change advisors for complicated, long reasons. And for some very odd reason, I decided it would be a good idea to go work with Clive Neal. Great decision, great decision. I knew next to nothing about Apollo samples, or about Apollo, or about the space race. So a lot of it I learned along the way from people like Clive, from David Kring, from a lot of you in this audience. And I've picked it up along the way. So most of my PhD and my postdoc and now what I work with now are Apollo samples. So scientifically and career-wise, I really would not be here without Apollo. But what I want to talk to you today about is actually education. So most of what I do at Western Carolina is teaching. It's a predominantly teaching university. And I teach the solar system, which is a 100-level astronomy class. In that class, they're non-science majors. It's not a lab. I have students who think we've been to the moon once. They can't tell me the mission. Some of them will know we've went to the moon for Apollo 11. Some of them think we went in Apollo 13. Because they've seen the movie, clearly they didn't pay much attention to the movie. They don't know why we went to the moon. They don't know about the national security issues. They certainly don't know about Mercury and Gemini. They don't know that there's orange soil. For those students, there's a question on my final exam that's basically what was a misconception that you had before this class, and talk about what that misconception was, how it's been cleared up. Or you can talk about opening your eyes moment about the solar system and how cool it is. And about 50% of my students talk about the space race, and that they didn't know anything about it, and that for them was really exciting. And my students pay so much attention in class for the few weeks that we talk about space exploration. And on their answers to the test, a lot of students talk about their newfound respect and inspiration for NASA, for the astronauts that were in Mercury and Gemini and Apollo, for the current astronauts, and particularly for those that risked their lives and some who gave their lives in pursuit of getting to the moon, and how much of an inspiration that was for them in the days before an iPhone. So a lot of what I do in terms of the importance of Apollo for me is education and helping students know the history behind it, how much was done in a very short amount of time. If you bring people together, look at what we can do. So inspiration and history for me in terms of inspiring the next generation of students, the next generation of voters, of why it's cool to go to the moon, why it's great to continue exploring, and you should never give up on that.
Okay, thank you. So, as Jake said, I was in Apollo, or in Houston, watching, among other things, the last rock bag get opened from 17, and if you do the math, that means I was an undergraduate. And it was an intriguing possibility. It was offered to me by a department chair that I had, and he knew Bill Finney, who ran the geology branch at JSC, who offered to have me come down. And I jumped at it and then realized I had no idea. what I was doing. I mean, I did, but I didn't. And I think one of my lasting impressions from that experience was, of course, all of us when we're undergraduates, we read papers, and I think all of us have this big revelation sometime when you find yourself talking to somebody who wrote a paper and being somewhat taken aback by that. And I think one of the things in my impression that I had before I went to Houston was that I was going to be, you know, in this sort of hallowed halls kind of thing. All these senior people that had done Apollo and that were doing Apollo. And I was pretty intimidated by that. I kind of felt like I was going to a monastery, and when I got there, I found out I'd gone to Animal House. And in retrospect, it all makes sense, because most of the people that did Apollo were in their 20s and 30s, and I mean most. If you go look at the demographics of the people that did Apollo, whether they were engineers or astronauts or scientists, most of them came right out of school in the early 60s and went on to do Apollo. And when the program ended, most of those people were barely past their 30th birthday, if they were that far at all. So they weren't much older than I. And it was a great revelation. And it sounds sort of silly, but I realized that these people were people, not names on papers. And they were very open. They were very accepting. Nobody ever made me feel like I was some dumb kid that was to be pushed off in the corner and kept quiet. And it was really, what? Good. What? And it was one of those magic things that sort of made me realize that a career doing what I've ended up doing was entirely possible. I ended up getting a master's at UNM. I had spent some time in the Army because I was on ROTC scholarship, then went to Arizona State, got my PhD, was out of the space business for a while, but came back in 1990 and did everything from science operations development for the Space Exploration Initiative. I ran a team for 11 years, upgrading the space station window and building the Window Observational Research Facility. You'll probably see at least one picture flash by here of some idiot in a spacesuit, and it was me, because I made the mistake of saying, well, I'd like to do that, and discovered how much fun, yes and no, it was. And then sort of ended my career about a year ago when I retired, finishing up by sort of, with Cindy's help and with Jake's help and a lot of other people's help, Jim and Jack, essentially taking what had been sort of a moribund is probably not the right term, but a fairly low-level program in the basic astronaut training curriculum, which would basically consisted of about 4 hours of lecture and then a field trip, and turning it into an honest-to-God 120-hour plus one whole week in the field doing field mapping, geologic training for all of the astronaut candidates that were in 2009 and 2013. In addition, we ran this radical idea of dragging engineers and managers in the field and throwing them out in the field with geologists and saying, hey, this is what we do, and this is why whenever you ask Dean, how many samples are you going to bring back, he sort of does a slow boil. And so in the course of that career, I managed to do all these crazy things, and most of them were things that either came out of my head or somebody came up and said, hey, would you like to do this? And I honestly don't think I would have had that chance if I hadn't gotten started on Apollo.
Great. So Jake asked us to talk a little bit about the experiences in Apollo and essentially what kind of guidelines they might provide for the future. So I'd like to try to cover a couple of points. The first one being explore the outliers. This is really something important. It's important to branch out and not be afraid of learning outside your comfort zone. This is really critical in any kind of space endeavor. When I got out of Brown University, I had a degree, a PhD in carbonate basin evolution in the Devonian of the Appalachians. Still looking for limestones. Haven't found any yet, okay? Maybe some little pieces on Mars. But the key here was that when I was looking for a job upon graduating, I picked up a college placement annual, which is a book of job things. I looked in the index and it said geologist, page 19 to 23, and 47. I said, what the hell is out there on 47? So I turned to that. It's a full-page ad. It's a picture of the moon, and it just says, our job is to think our way to the moon and back. And there's a phone number in the bottom. I said, holy Jesus, how do you do that? You know, I mean, how do you think your way to the moon and back? Called a number, got an interview, got the job. It was at NASA headquarters working in the Apollo program. So, you know, don't be afraid to look at the outliers there. It really pays off. It certainly did for me. Again, still looking for limestones.
And page 48.
48. So another thing is to learn to adapt and adapt to learn. My job title when I got to NASA headquarters working in the Apollo program was systems engineer. I had never had a course in engineering. I didn't even know what systems engineering was. But I quickly learned, in fact, it was thinking our way to the moon and back. This was amazing. You had to reach out and really learn a huge amount. You had to learn a lot of engineering. You had to learn a lot about other disciplines. And this is a critically important part of space exploration. It's a completely interdisciplinary effort. Don't be afraid to do that. In fact, cultivate that. That's one of the beautiful things about Survey and the kinds of things we're doing here with human and robotic exploration. It's just really important. You really need to learn to be comfortable outside your comfort zone, because anybody in a space program will welcome those views. They want to learn from you, and you certainly want to learn from them. The third thing is that practice science and engineering synergism. This is something that I think was the most critical thing I learned in the Apollo program. We had a major goal to get humans to the moon and return them from there safely by the end of the decade. That wasn't something you could just do independently. It was a team. It was an incredible team, okay? And the idea was that you work with the engineers, shoulder to shoulder with the engineers every day. A little rough going in the beginning. You know, the idea of sending a human to the moon and returning them safely. Oh, you want to get out of the lunar module and you want to actually pick up rocks and you want to walk around and get, you know, Jesus, that could challenge our mission success criteria here. And on the other hand, everybody worked hard, and particularly Jack Schmitt, worked hard to encourage the engineers and the scientists to talk together, and we began to really work shoulder to shoulder. The best piece of advice I can offer you is to really cultivate the engineering community, have them make your dreams a reality. You know, you can put sandbags in space, no problem, okay? You want to encourage them to make your dreams a reality. At Brown, we try to get the students together from both science and engineering, planetary science and engineering, together at the beginning. We design missions together. My students serve as the design reference mission, PDR and CDR kind of reviews, and it's great. They learn how to work shoulder to shoulder. This is critically important, and I think was one of the big successes of Apollo. By Apollo 17, I remember a meeting we had with FOD, Flight Operations Director, and the site selection group. Basically, the landing ellipse would not fit in the Taurus-Littrow Valley, okay? That means you're not going to land there. Well, one of the key people said, okay, engineers, I know you all have a 10% or 8% pad on your estimates here. We're going to meet at 9 o'clock in the morning, and oh, by the way, that ellipse is going to fit into this valley. Go scrub your pads and get together and tell me that's the case. Funny thing, it worked, and that's why we got to Taurus-Littrow in the bottom line. So, you know, this was great. Everybody wanted to get there. The people understood the goals and objectives, and it wasn't a can't-do kind of situation. It was a can-do kind of situation. You hear that term a lot, but in fact, these people were facilitators, not gatekeepers. It's amazing, okay? That's why we were so successful, I think, in Apollo. Another thing is to, in fact, utilize the seductive nature of field geology, okay? Now, you know, many of us, that was what we grew up on, okay? But the fact of the matter is, early on, Jack and Lee Silver and other colleagues, Gordon Swan, Bill Mulberger, et cetera, and Gene Shoemaker, in fact, were really critical in telling people the importance of geology. Essentially looking at observational science and learning how that you can make observations and select samples on the basis of your observations and really make that work in terms of a scientific endeavor. This is not a trivial thing to do, and it doesn't make a lot of sense in many cases to engineers. You get out, you wander around, you look around, then you decide what to do. No, you don't want to do that. You want to have it all organized, okay? So the key thing here is that essentially by the brilliant move of taking, of course the astronauts went into the field, but taking the managers, essentially the program directors, the flight directors, and all the other engineers out in the field to see how it all worked was one of the key reasons for the success of Apollo, because they were all behind us by this time and in fact figured out how to optimize. You know, I worked, you'll never have heard of this before, I worked on Apollo 19, 20, 21 missions, okay? And these were dual mode rovers, okay? So the engineers had figured out a way where we could actually take the rover that you took to the moon, add some pieces on the back, essentially power it and then send it off to the next landing site so it could do a traverse between the landing sites. And we had a whole payload, sets of payloads, gravimetry, seismic. Oh, it's incredible. Okay, this never happened because the missions were canceled. But in fact, you could see where this was going. Apollo was a lunar exploration program. A couple of words about astronaut training. First of all, something about the pre-mission planning of traverses. We did plan the traverses prior to the mission. Nothing upsets me more, a lot upsets me, okay, but nothing upsets me more than hearing that Apollo was scripted, okay, because only an idiot would go in the field without a plan, in the geological sense, okay, and unless you're on a vacation, you just don't go into the field without a plan, okay. So the Apollo traverse plans were not immutable and relied heavily on astronauts determining, in fact, the observations on the spot and the detailed analysis that they were able to do and that we were able to do on the ground. And we did have communications and debriefings when they were back in the lunar module and on-spot decisions, et cetera. But in fact, they were not immutable scripts that they were following on the surface. I think our credo, if you will, the concept in crew training, at least from my perspective, was teach problem solving at all levels, not just facts and rocks, okay? And that's essentially what they did. The Apollo Astronaut Training credo is also something like TTT, train them, trust them, and then turn them loose. We're not sitting on the ground waiting. So what do you think? Oh, I need help here. What color is this rock? What do you think I ought to do? Pick it up? No way. No way. That's a lesson for the future as well. Leave the exploration to the astronauts. And again, you listen to people like Jack and Dave Scott. Dave Scott told me that when he was inside his spacesuit after they finished setting up all the instruments, et cetera, and going on his geological traverses, he did not even know, he was so excited about the geology, he did not even know that he was in a spacesuit. Now, I got to tell you, that for me, I think I'd kind of look up at the Earth, and he was like just in the, as he describes it, in a sport metaphor, he was totally in the zone. He was totally in an exploration zone. We need to be sure to let the astronauts be able to do that, get in that zone, optimize the human capabilities as we explore the planets, okay? And so that means a lot. It means us working with the engineers to, in fact, optimize robotics to do the task that astronauts have commonly done in the past. There is no reason, in principle, that with robotics of the present and the future, we couldn't get things like ALSEP set up and have data transmitted back on their own. Another corollary to that, Jack alluded to this a few minutes ago, is that we don't need a geological robot field assistant, okay? Because the last thing, I'm telling you, all the Apollo astronauts would just cringe at this because they don't want to be technicians, okay? They don't want to be, oh, the wheel fell off. Well, okay, get out the toolkit, let's get a spare tire. That's not what they want to do. They want to explore, okay? So this is something we really need to critically keep in mind as well. I think when you think about it, too, not only leaving the exploration of the astronauts, but remember that astronauts, I can't imagine a better group of students than those that were in the Apollo program. No offense to any of my students who are exceptional, okay? I'm serious about that. But in fact, when you think about all these extremely highly motivated people who are going to, believe me, they're excellent students. And I would just tell you things like Dave Scott, okay? So when he looks meters away and says, Houston, I think we found what we came for, because he saw the Genesis rock, plagioclase twinning, shining in the sun, and he knew exactly what that was. It was deep crustal material, large grain size, and he bagged it, okay? And secondly, on the way back, Houston, we got a problem here. Oh my God, what's the problem? Better get back, you're running low on oxygen. No, wait, the seatbelt's broken, okay? Oh, well, get off and fix the seatbelt. David spotted this vesicular basalt. We talked about volatiles on the moon, how important it was. He saw that thing sitting there, stopped, got off, did it without mission control's knowledge, and then got back off. Seatbelt's working great. Okay, get back. So that's the kind of sense you need, okay? These are not geologists. Jack did an exceptional job. These people did really great jobs with the geological training they had. So cherish that. And I think the most important thing is that the term is not mission control. The term is mission control, not astronaut control. And the role of the science back room ought to be to facilitate, but not to control, okay? It is to, in fact, give these people the background they need, brief them, debrief them after they get back into their vehicle or habitat or module or whatever. And finally, I think here's the bottom line to me. We should stop trying to control what the astronaut's going to be doing on the surface. We're talking about humans on another planetary body in the next decade or so. So instead of thinking about how we're going to control the astronauts, Let's think how you become the astronauts. You're all planetary geoscientists of some sort in here. Let's not wait around to tell people what to do. Let's be those people. There's no reason why anybody in this room shouldn't be on the missions in the future. And so I think these are really important lessons to me anyway, because they seem to work at the time. There's great vision for the future, and I hope that we'll be able to be around when all of you are walking across the surface of another planetary body telling us what to do. Thanks.
Thanks, Jim. I want to start in 1968, about August. By that time, Mercury had flown, Jim and I was flying. I had a PhD, had spent a year with Shoemaker, was in pilot training for a while, and then helicopter training. But in 1968, in August, we had a problem. The lunar module was 6 months behind, was the estimate. There was at that time a pogo problem in the Saturn V that needed to be fixed. And George Low, the Apollo spacecraft program manager, decided that we should go around the moon, keep the momentum of the program, and should reprogram an Earth orbit mission scheduled for later the next year to be Apollo 8, that is a lunar orbit mission. George happened to be very familiar with this. He had studied it years before as part of the Space Task Group under Bob Gilruth, and he was extremely comfortable, and it took him about a month to convince everybody else to be comfortable with this. Von Braun turned out to be very, very enthusiastic about it, but it meant that if the first manned use of a Saturn system and the Apollo system were successful, namely Apollo 7, and launched in November of 1968, then we would take Apollo 8 around the moon. And the first deep space use of the Saturn V and a crewed use of the Saturn V would be a lunar mission. Very, very important decision, and we owe George Low a great deal about it because it kept the momentum going so that Jim McDivitt's Apollo 9 mission, after the success of the Apollo 7 mission, the first use of the command module after the fire at the Cape in 1967, after that success, it meant that Jim McDivitt's use of the lunar module in lunar orbit, and then its use by Tom Stafford and his crew, which included, by the way, Gene Cernan and John Young, that with Apollo 10, also a lunar orbit mission, but with the lunar module in tow. And then Apollo 11 became realistic as the first lunar landing. All these missions had letter numbers at the time. They didn't receive their actual mission numbers until they were formally announced. So Neil and Buzz and Mike Collins went to the moon in July of 1969 after the success of all these other missions. And then the Apollo 12 was launched in November of 1969. And I want you to do some math here. Between November of 1968 and November of 1969, we launched essentially a Saturn V class mission every 2 months. And the context here, as already indicated by Dean, was that these engineers that were making it all happen, independent of the scientists wandering around trying to get more out of each mission, the average age of these engineers was in early 20s or mid-20s. Early 20s or mid-20s. So keep that in mind. That's where you do great things. And it's been true throughout at least the history of the United States. Great things are done by young people. There may be a few managers around hanging on, but what really is important is what those young people do. When I arrived in Houston, and began to look over the status of astronaut training in science, and I'd already experienced some of it, having been an instructor myself in a couple trips. I decided that maybe we ought to be doing it differently, because after the first lunar landing, we needed to get the crews, the potential crews in the future, not only excited about what they were going to do, but also get them up to speed to have as much observational experience in geology as we possibly could provide. And so I went to Al Shepard and suggested with a memo that we take over, the astronaut office take over the training of the astronauts in science. Up to that time, it had been left to other parts of NASA to supervise that training. And the U.S. Geological Survey was deeply involved all through this. And the idea, though, that I presented to Al was that we base the training on simulations in the field, that we do what we had been doing with other spacecraft operations, and we use simulation. But we do it on real-world problems. And Al's response was, well, if you can convince Jim Lovell, who was up for Apollo 13, to take this on, well, then go ahead. Well, Jim was no problem at all. Jim was enthusiastic. We began to implement that training. Actually, there was some feedback back into Apollo 12 by that time. And so this simulation-based training program was put into place and affected every crew from then on. And by the time Apollo 17 came along, all the crews had been through some aspect of this simulation training, most of them through complete training, 15 months with about a week a month in the field, simulating their mission. And to the degree possible, and most of you know that it's not really very possible, but to the degree possible, we tried to gear the training sites to what we expected they might find on the moon. And a good example of that is what Jim has just described, Dave Scott noticing the Plagioclase 20 in an anorthosite collected at the Apollo 15 Hadley Reel site. Two of his trips, of the field trips for that crew, Apollo 15 crew, had been on anorthosites, one in Minnesota and one in California. So that paid off, I think, to some degree, that they actually ran simulated missions using all the equipment that we could, except for the spacesuits, and on anorthositic rock terrain. With Apollo 17, we had an interesting situation. My boss, Deke Slayton, recommended that the crew for Apollo 17 be in a relatively normal sequence, not always adhered to, the backup crew of Apollo 14, namely Gene Cernan, Ron Evans, and Joe Engle. He sent that recommendation to NASA headquarters. NASA headquarters sent it back to him saying, you have to find a way to fly Jack Schmitt to the moon, literally. And so Slayton had two choices. He could substitute the Apollo 15 backup crew, Dick Gordon, Vance Brannon, and myself, for that 17 crew, or he could just substitute me for Joe Engle, and he chose the latter. It took a while for that crew to gel, but it didn't take very long. Everybody was professional in this game, and we were moving along extremely well. Ron Evans turned out to be, in my experience, probably the best command module pilot that ever flew. He really dedicated himself to learning the command module, its procedures and everything. And every time Gene would try to take over as commander on some procedure, there would be some reason for Ron to take over from him. You can understand commanders wanting to be commanding, but nevertheless, Ron knew that spacecraft, and he really operated it beautifully. He probably did the best job of anybody on operating the scientific equipment bay, the SIM bay, kind of instrument bay, I guess it was, the acronym. And so Ron really deserves a tremendous amount of credit for what he provided to science as well as to the operations of Apollo 17. Gene had been on Apollo 14, as I indicated previously. The mentor for Apollo 14 was Richard Johns. Some of you may remember that name. Caltech professor of mine and outstanding field geologist, and that's as well as an outstanding scientist. And that's the reason that I asked him if he would be the mentor for that crew. Unfortunately, Al Shepard, in spite of his agreement to the training program, was not as enthusiastic about the geology as we would have liked. And Gene did not get exposed to as much as we had hoped, but very quickly during the Apollo 17 training, with that week a month out in the field, he turned into an outstanding observer, as well as being very interested in what geology Taurus Littoral might provide. So you can see the complexities of what went into ultimately providing us with a large number of remarkable samples that have come from the Apollo program. As Clive and I have often said, it's a gift that gives on giving and will indefinitely. As analytical technologies and ideas mature, I see no limit to what we can learn from these samples. That Apollo 17 mission provided us with an opportunity to get into the most diverse area that we explored on the moon. We had 3 dimensions. Believe me, that valley's deeper than the Grand Canyon, so there's 3 dimensions there. As well as many, and increasingly we're finding diverse geological units that we could study. Jim mentioned the problem of getting into the valley, and actually I think that during that night, those flight controllers, MPAD, as we call it, Mission Planning and Analysis Group, went back and realized that if they waited one orbit to give the lunar module an update based on Ron Evans' sightings of landmarks in the valley of Taurus Littoral, that ellipse could be shrunk to a 1 kilometer ellipse. I don't think they just shrunk it willy-nilly. They actually had reason to shrink it to a 1 kilometer, 3 sigma, which is very conservative, by the way. By that time, we had landed within a few hundred meters of the planned landing sites on every mission, with the exception of Apollo 15. And there we ran into some MASCON, our gravity issues, that really had not been anticipated, and they were off a bit compared to the other missions. But ladies and gentlemen, it really was a remarkable period in human history, one which had its origins, of course, in the Cold War, but one which people like George Low and Sam Phillips and Bob Gilruth and others realized could do much more than just solve one of the problems of the Cold War. And as a result, even with the cancellation of the last 3 Saturn V missions to the moon, we did benefit. We in this room and science in general benefited tremendously from what has come out of that mission and those missions. With that, let's get some questions.
Okay, does this work? Yeah, can you hear me? Okay. So Jack, I'm going to take advantage of having the first question. Amy and Dean and Jim all talked about sort of right turns in their early career pathway to the moon. You did not start off as a lunar scientist. How did you? I believe as you were a newly minted PhD, you were doing work in Norway. Is that correct?
My PhD work was in Western Norway.
Okay.
It was in the high-grade metamorphics of Western Norway, eclogite facies metamorphosed in the sillimanite zone, for those of you who are into high-grade metamorphics. When I had finished my PhD work, I didn't see any real opportunities for employment, so I was fortunate enough to have an NSF fellowship for a year, postdoc fellowship. And in that year, I began to look around again for employment. There wasn't much going on, and it was a recession in geology, as often as, unfortunately, is the case of a cyclic profession of that kind. And I had met Gene Shoemaker out in Menlo Park when I visited Bob Coleman to look at some of the eclogites of California in the Franciscan Formation. And when I met Bob, he said, before you leave here, you need to go down the hall and see what this crazy guy Shoemaker's doing. He's actually mapping the moon. Can you imagine that? Or words to that effect. And so I went down, met Gene, Danny Milton. Some of you may remember Danny, tremendously bright guy, was working with Gene as well as Don Wilhelms and people like that. And I was so impressed that it sort of stuck in the back of my mind. And so when I couldn't see anything else to do, I wrote Gene a letter and asked him if he was looking for any geologists. And it turns out our letters crossed in the mail, literally. He had written me because he had seen my name on the, as having taken the civil service exam for geologists. And so we connected, and in July of 1964, I was in Flagstaff mapping the moon, as well as starting to think about the kinds of things that Dean has thought much more about recently, and that is, how do you actually do geology on the moon? Gordon Swan and I were out in the field in the Hopi Buttes doing all sorts of crazy things about photography and tools, and you can't imagine some of the silly things that we tried in order to try to get a better understanding of what could you actually do in a pressure suit when you're on the moon. And some of that actually fed back into what ultimately happened. One of the things that happened during that period of time was that Ranger 9, I believe it was, impacted the moon and gave us a high-resolution shot right at the end of the lunar surface. And Gene says, why don't you plan a traverse on that photograph? And I did, and I think it's the first time anybody tried to plan a traverse on a lunar photograph. It's available somewhere. I'm not sure where. Somebody sent me a copy of it the other day. I hope that answers your question.
Yeah.
Madhu Thangavelu from the University of Southern California. It's a delight to see and hear you talk about human exploration of the moon again. And my question is, can any of you or all of you tell us a little bit more about what NASA's plans are to return people to the surface of the moon? Jack first, perhaps.
Well, I am totally out of the loop on that, so I'm going to defer to people who might be in the loop.
I'll say something about that. Vice President Pence, a few days ago, made some comments about future space exploration, and he's now, the restarted National Space Council. There's those words again, which is a great thing, I think, okay. One of those comments about a major goal and objective was, in fact, to return to the moon and then on to Mars. Now, you can say, well, that's going to be in, some kind of orbit thing where we don't get to the surface. I think that what we need to do is to become proactive about this, take the words return to the moon, and assume, this is the era of transient reality, so whatever we say will become infectious. And literally, let's say the vice president said we're going back to the moon. That, to me, says to the surface, okay? So, I think there's a lot of room in there. The real direct answer is that I don't think we know yet, okay? There's no director of NASA. The Space Council and the Vice President are involved in the broad-scale decisions about space for the nation as a whole. But I would hope that we could exert pressure, literally, to get that return to the moon. Because I think no Apollo astronaut would feel comfortable with the idea that we went directly to Mars without going back to the moon and learning how to do it again, surface exploration.
So I'm retired from NASA, so I probably can't get in trouble.
Oh, yes, you can.
Of course, I've been in trouble plenty of times. But one of the things I will say is, so one of the reasons I ended up testing spacesuits was because Joe Cosmo, who up until the time of his retirement with 51 years working for NASA, at that time had helped either been the prime designer or helped design every US spacesuit from the Mercury suit all the way through the shuttle suit. Joe came to me and said, you know, I can probably try and teach an engineer what a geologist does, but he said that's probably a futile effort. I can get you in a spacesuit and you can tell me in one suit run whether the suits I have are going to do the job or not. And that started a 10-year association between Joe and I that actually as a friendship exists to this day. And the important thing is that started in 1996. And so the point simply is whatever the upper level guys are doing, the managers and the White House and the Congress and all that stuff, the youngsters down low understand that we are going someplace and they're working on being ready to get there. So I think as far as most people think, it's merely what's the starting time, not you want us to what? And that's been the spirit I've seen throughout the agency for a long time. And so, you know, eventually the policy will catch up to where the engineers and scientists are. So.
I might just add, if you want to know what my recommendation has been, I gave testimony to Lamar Smith's Science Committee in the House in March, along with Tom Stafford and others. And it basically is that if you want to go to Mars, you better go by way of the moon, because there's so much to learn, and we need to have a generation or two get knowledgeable about how to deal with the risks of deep space.
Hi, my name is Benjamin Fagan. I'm currently an unemployed research scientist that's transdisciplinary. So Jim, your talk specifically hit right at home for me, so I appreciate your words today. But I work with hardware and software development, very transdisciplinary in life support systems. And due to that, I found that a lot of HR keyword rounds, as well as academic professions, have come to idolize specialization as opposed to a transdisciplinary or integration approach, and it seems there's no room for that in practice or in recruitment. So what advice might you have for job seekers or for agencies in recruitment processes that might give value to these elements that you're discussing?
It's a difficult question to answer. I think, you know, your talents in interdisciplinary, multidisciplinary work are really very valuable. There's absolutely no question about that. And I'm sure in industry and space programs that you eventually will find, you know, a very important home. I think academia is a little more difficult, although with environmental science and things like that, they're becoming infinitely more multidisciplinary, as is geosciences. You know, I think our students at Brown and planetary geoscience take more courses from the rest of the department, from engineering and physics and math, et cetera, than any of the other students in geosciences, because they obviously need that, because it's an interdisciplinary field. I think it's critical to be able to have an area of expertise. I like to visualize scientific success in some ways as being really well trained in the kind of median area of a bell curve, if you will, but also to explore 2 to 3 sigma interacting with other fields that are kind of like in the same way. So geology, geophysics, astronomy, et cetera, et cetera. This is really critical. It helps to have a fundamental strength, but then, you know, as I said, think outside your comfort zone and explore and essentially engage and become friends with, just like we do every day here at these meetings, okay? Network, so that you know, the multidisciplinary and interdisciplinary talents you have can be recognized and taken advantage of. I'm sure you'll be successful. I think one of the best things I can tell you is that virtually every career is extremely nonlinear, okay, in terms of where you go and what you do. You know, I haven't, you know, I just wrote abstracts for the 4th Early Mars Conference on using a stratigraphic approach to understand the Noachian period of Mars history. So I'm still doing stratigraphy, but in fact, we do have some carbonates there, but not many, okay? So I really encourage you to press on, and I'm sure you'll find your path, okay?
One thing to remember is that when you're in your 20s, you can work the 16-hour days, 8-day weeks that are required in order to not only concentrate and perform well in your specialty, but to, on your own time, broaden your understanding of other areas, just as Jim has indicated. That's why these programs are programs of young people, because they have the stamina, the motivation, the courage, and the lack of failure, knowledge of failure, that makes it possible to go forward.
I think I spent about half my career with engineers thinking I was a scientist and scientists thinking I was an engineer. I think that means I was successful, but I'm never sure. But the bottom line is that I sort of delved into different areas, different Venn diagrams and where they connected. And that was how I got done what I got done. If I had been hard over as no, I'm only a geologist, I probably would still be out there working instead of retired, and maybe I wouldn't be working. I think, like both Jack and Jim said, you make your career out of the opportunities that come to you, and you should never say, no, I'm not going to do that. That's not what I do.
I would just a little Halliburty there. I think, if you only had to listen to Sam Lawrence's talk this morning to understand the very sinuous path from his dream, what he heard in his dream, okay, his inspiration, Wendell Mendel, and thinking about exactly this inspirational person to actually getting his job, okay? So think about that. That was a beautiful example of the kind of thing we're talking about. And also, it's a good example. Thank you, Jack.
I don't think mine's working.
It's a good example of why it's so important to do outreach, okay, for all of us, okay, because essentially you could see from Sam Lawrence's discussion, how inspirational that was to him, and it propelled him on a nonlinear but very productive path to now holding his dream job. So that's it.
When I was in my late 20s, and I want to hear Amy's comments on that question, but when I was in my 20s, I was learning to fly T-38 aircraft. But in the evenings, I was working and moving towards publishing the geologic map of the Copernicus quadrangle, one that Shoemaker never finished. And Newell Trask and I, with Shoemaker as the junior author, and that was always great to feel that, actually put that together during the same year I was in pilot training. So that's what you have to do. You got to use the whole 9 yards of your time. And if you don't, you'll probably stagnate in one discipline somewhere.
Well, let's see, is this on? When I was a graduate student and I would come to this meeting or go to LPSC, I always asked other people, mostly senior people, how they got to where they were. And you're right, it's very sinuous, but it's a great way to start talking to people. And what I learned from those stories is that, again, nobody had a linear path, and it almost, to me as a graduate student, seemed like some sort of magical fairy gave them and granted them their wish, and they got their perfect job. And, well, that was never going to happen to me, and that was never going to happen to anyone else I knew, because these people were just so highly intelligent and special, and they had magical fairy dust. But after several years of asking the same question, of many people in this room, I know I've asked a lot of people in this room that question, what I learned is that they got to the different weird little places in their path because they talked to people. If you are a graduate student and you're not talking to people in this room, then it's going to be really tough. But the more people that you know in this community, the more links you're going to have, the more people are going to know what special talents you have, and when they need something that you can give, they're going to be able to think of you. But if they don't know you, they're not going to be able to think of you quite as quickly. And earlier on in the day, a lot of people talked about mentoring and community, and that's what's so great about this community, that we really help each other out, particularly with the young people. But the ball's really in the younger people's court. It's a challenge. It's a little scary, but I've found that anybody that I've gone up to talk to in this room has been helpful and welcoming. And even if you just want to go up and say, so how did you get to where you are? Everybody loves telling that story. And it's a great way to open a conversation. And it's just it's gonna flow naturally to have a conversation. And the more people you know in the community, the better.
There was something I saw once where somebody said that, and I think this applies to your career, there's very few mistakes you can make that will lead to a life of woe and sorrow. Okay? Short of, embezzling funds or doing something stupid like that. If somebody offers you an opportunity, take it. Twice I got offered opportunities on the phone that I didn't expect would be coming, and I had to make a decision on the phone at that time. And one thing that went through my head in both cases, if I don't jump at this now, it ain't gonna come again. And if I had said, well, let me think about it, it would have been gone. And I had no idea whether those were gonna be successful or not. They turned out to be, but I didn't know that at the time. So learn not to fear sudden decisions, because that's where the most fun happens to you, is when somebody calls you on the phone and say, hey, it's a great job, do you want it? So.
Erica Jowen, Brown University. So my question really feeds off nicely from what Amy was just saying. And so there's so much really incredible experience and expertise from the Apollo era on this panel right now. And selfishly, as someone who would like to be one of those 20, 30-year-olds in the room the next time we go to the moon, or Mars, hopefully the moon, how can we translate all of this experience and expertise and intuition that was developed through the Apollo era to the younger generation of scientists and engineers who are going to be the ones in the room making those decisions the next time?
The most important thing I think you can do is to learn about that history, but then apply it to the current situation to the degree that it's relevant. Some of it's not relevant. Let's remember that. Things have changed. Hardware, software changes are just unbelievable. Materials are different. So it's the next time we go to the moon is going to be different than it was the first time. The basic physics isn't changing, and that's the thing you really have to know. And the basic mathematics is not changing, and you have to have mathematics as a language that you can use at any time. I wish I had had that. I just, my background in high school and college just did not give me math as a language. I wish it had. If I had one particular discipline that is critical to everybody in this room, one way or another, it's mathematics. Now, how did I get on that?
So I'd like to contribute to that conversation, too. I think Erica Jowen at Brown, and also Tess Caswell, who is a Houston International Space Station flight controller that came to Brown to do her PhD in essentially the mechanics of ices on outer planet satellites, came to me and asked me this very question, and we've planned, and I think this was discussed in the Survey Executive Committee meeting on Monday, to in fact have a Survey course potentially at Brown, hosted by Brown, like we did with the Phobos Deimos course, on just this kind of thing. And I'd like to publicly ask Jack if he would be involved in that. I'm sure he will. Because we'll have, like we did then, I think some of this history, really lay this out as you all requested. They put together a really great plan, and I think we're going to have further discussions on that and try to implement that. So there is an opportunity to learn about that history, and again, how it applies and doesn't apply to the future, but give you an opportunity to have the tools which you can use to recognize and take advantage of these situations as they come along. But just one other comment here I think that's really important about the Apollo program. One of the things we've all heard about the international competition that led to Apollo, the Kennedy speech at Rice University, and essentially beating the Russians and getting ahead in the space program. But I have to tell you, as a participant of the Apollo program from Apollo 7 to 17, in fact, in detail, I don't remember one single day where we said, gee, are we ahead of the Russians? Are we going to beat the Russians? The bottom line was that this incredible, magnificent goal that the president had put forth was like, oh my God, can we do that? Can we do that? And none of us knew, okay? But you can be sure we were going to make it happen if it was we had anything to do with it. And that bred a culture of collaboration that, in fact, was incredible. I mean, I can remember many meetings where, essentially everybody in the room and these are mission review meetings. Is Apollo 15 ready to launch? If you had anything to say, you better say it. Even the lowest person was expected to say anything they had in their mind, and then they were listened to. If somebody, I don't remember this happening very much at all, but if somebody said, oh, that dingbat over there is such a jerk, so-and-so, you know, the response to that would be, can you hold that thought? We're launching next Tuesday, okay? So the kind of like carping that goes on a lot, stuff, not a place in Apollo. I mean, like, not a place. It was a goal, it was a mission. It wasn't about beating the Russians from our point of view. It was, could we do this? So work to get a goal like that. You will learn what partnerships, what collaboration, what teamwork can do, and I think it benefits everybody. It's certainly from the point of view of what Apollo did for the United States, okay, which was pride and prestige. Pride, how we view ourselves, and prestige, how others view us, was gold, okay? Just pure, solid gold. So I hope we can find a way to do that, and I think international cooperation is going to be the coin of the realm in the future as well. So may you all be blessed with the opportunities we have, and I hope we can teach the basics in this course to at least put you in a position to formulate, to make that so. Thank you.
In fairness, Jim hung out with different people than I did.
Yeah, I'm telling you, there's a lesson there, okay?
Yeah, I'll tell you, the patriotism that was involved in Apollo was very, very much in evidence. And
Patriotism, yep.
yes, and it was
Absolutely.
part of the Cold War.
Absolutely.
Many of you do not remember the Cold War. It was a very serious time, and it was very serious to most of the people, at least at the Johnson Space Center, that I interacted with. And one aspect of that interaction was, and this is, I think, more directly in response to your question, is that during a test or a simulation or something, a hardware, software, or operational problem appeared, that evening, spontaneously, it seemed to me, a bunch of young 20-year-olds would be meeting in a room, figuring out, one, what caused the problem, what are the possible reasons that we had a problem, and what are the possible options for correcting that problem. And the next morning, the managers above them had those options in front of them. That's why we could do a mission every 2 months, because that kind of young, spontaneous initiative existed. And also, I don't know whether there were any others, but Jim may recall that in my apartment, we were thinking on ahead of what was going on. There was a group, we called ourselves the Lunar Mafia, and it included flight controllers, scientists, other engineers, and managers. And we, over beer and popcorn, we would be looking at all sorts of different things that might be done. That's where the idea of putting Apollo 17 on the far side of the moon ever came from, was that group getting together and thinking about it. And in the process, they would go off the next day, sometimes to their detriment, and try to figure out, how do you do that? In fact, Gene Kranz called me into his office once and said, what is this that you've got Llewellyn doing these days? And I said, what do you mean? He said, well, he's running on the computer a bunch of operational profiles about how you get to the crater Tsiolkovsky. He said, we're not going there. And I said, well, gee, I didn't know that he was doing that, and it's my fault because the idea came up in our group. But that was what was happening, and just remember that. You know, take opportunities to think for yourself, to think out of the box, as Jim has said, and you can be amazed at what comes out of those kinds of interactions, particularly among young people. The value of their ideas is far greater than the individuals that are there.
I just want to give a little clarification of my point too, which is that basically I was talking about at the working level in terms of worrying about the Russians. There's no doubt that at the higher levels there was the question. You know, the president's goal was not just to land humans on the moon, but was a broader international policy effort. And I would just say, for example, the Apollo 8 thing that Jack mentioned with George Low making these decisions. You know, it was known at that time, not necessarily to me, but that the Soviets had a launch vehicle on the launch pad, and it was human rated to the moon, and that they might launch it in early December. And so there was pressure there, and I know that fed into, in part at least, the decision for Apollo 8. So absolutely no question. And patriotism, no question about that, okay? I mean, we all felt very proud of our ability as an American citizen to actually work together to create this goal. One last point here too. I remember that I worked at NASA headquarters. So I worked very closely with the Apollo program directors and managers, et cetera. Would brief them on what was going on, et cetera, blah, blah, blah. And I remember about a month before the Apollo 11 launch, I got this brain kind of like, whatever, epiphany, I guess would be the word. Why don't we, wouldn't it be wonderful to take the flags of all the nations to the moon on Apollo 11, be able to present them? So I thought this was a great idea. And so I went to the Apollo program director and I said, hey, I got this idea. He said, don't worry, Jim, it's being taken care of. So even then, thinking about the impact of this internationally, and actually even though the American flag was planted, taking all those flags to the moon and returning them to the Earth and distributing them among all the countries of the Earth with a sample was actually done. So I think that's, to me, very inspirational.
Jim, I was at the working level too, and it was certainly a major motivating factor. But let me ask you a question. Does anybody in here know what the first partnership we had internationally with Apollo? And who was responsible? It was Gene Shoemaker. Gene was chairing the subcommittee of the planetology subcommittee of the Space Science
Board, no.
Board?
Yeah.
Yeah, Space Science Board. And he insisted that the sample analysis program be open internationally. And he succeeded in that. And as a consequence, we had 4 teams, one from Japan, one from Switzerland, I think 2 from Germany. Does anybody remember exactly? I think that was, I know there were 4 teams that were in the mix and received some of the first lunar samples. So science had a great deal to do with what Jim has been talking about, of getting international participation in space. And it was the sample analysis program. And you can thank Gene for it.
I just wanted to put in a little bit of a idea of ways that you can get educated about the history of Apollo, because these guys all lived it. It's a little bit challenging when you weren't around. Some of the ways that I do not pretend to be even close to the expertise level of these gentlemen here, but some of the ways that I've learned some of the stories about Apollo is by talking to these guys and by talking to other people in this room. For example, Jim's story of his aunt who was in the CIA, who was horrified that he was tracking Sputnik with his radio. That's actually, I tell my astronomy students that story. They like that. So, using things like that to help students understand, hey, Sputnik was a big deal. I learned the story of Seatbelt Rock from David Kring. A lot of these stories, it's hard to find written down in one place. Even the excitement of Jack on the moon with finding orange soil. But you can find some of that stuff, at least the things on the surface, through the Lunar Surface Journal, which you can find online. And you can go through the transcripts and see what they said, and you can find photographs that are connected to that time period of when they said that. You can see the photograph, and for me that was really helpful to kind of connect things together. And it's also really fun to read through what they're saying. At least I had it in my head that the Apollo astronauts were all very straight-laced, very serious people. Correcting misconceptions is a very important thing. And so some of that, reading through some of those transcripts and seeing how excited they were was important to me. And I wanted to learn more, and I kept reading and reading and reading. And so I know I have a long ways to go, but it's a good place to start.
Let me suggest, Amy, if I may, some reading materials that gives you a flavor. I think one of the best from the crew point of view was the first, and that is Carrying the Fire by Michael Collins. One of the best from the flight control side of things was Gene Kranz's book, Failure's Not an Option. Another one from crew managerial point of view is Deke Slayton's book, Deke. It reads just like Deke wrote it, and I think he dictated it. No question about it. It was late in his life, and
There's a lot of bad words in it.
Well, they trimmed those out.
Chris Kraft's book, Flight,
That's
is an excellent book from that perspective. So there are some books out there that are well worth your time. Put them by your bedside, read a chapter or two a night, and you'll get a good flavor for it. Now, it doesn't have all the little stories, the nuances. You got to, as Amy says, you got to talk to people to get those little stories out of it. For example, when Gene unfortunately broke the fender off our lunar rover, he was really worried about it, and I spent a great deal of time off tape in the cabin trying to convince him about what was going on in mission control as he was fretting, because I had done it before. The guys had dumped everything we had in the cabin. They knew exactly what we had in the cabin, dumped it on a table, stared at it, and said, "How do we fix that fender?" And they fixed. By the morning, they had a fix for the broken fender, and it worked beautifully.
It was the geological maps.
Yeah,
tape with duct tape. I mean, some were happy, some were not. Okay.
But it's just that when you have that kind of experience, and those stories are very important to remember, that it was these young people getting together and solving a problem and doing it almost instantaneously.
So Jack, I actually just recently learned that story from Larry Taylor.
Oh, yeah.
I brought my mineralogy students to UT to use the electron microprobe, and I leave half of them with Larry to experience Larry. And they learn about diamonds, they learn about all sorts of other things. But that was the first time that I'd heard that story from Larry. And so you never know when you're going to learn some of these cool stories.
But you always have to remember that at this stage of the game, sometimes those stories have been modified. And one modification of that story is that generally you'll read that John Young, and I don't want to take anything away from John, he's a great guy and a great commander on Apollo 16 as well as other missions. But it wasn't John. John just did the simulation to prove that it could be done. It was Denny Holt, I think.
Holt, yeah.
Yeah, that came up with the idea about how to fix that fender, and to use the light clamps to put it on the remaining part of the fender and things like that. It was one of these 20-year-olds that made that solution possible. So just remember that you don't always, the hearsay stories are great, and sometimes they're right, and sometimes they have little errors.
All right, well, thank you all.
One last comment. One last comment. Yeah, one last comment. Sorry.
One more comment.
Yeah, it'll be short. So I really want to thank Cindy Evans, Dean Eppler, and Jake for carrying the fire. I mean, they've just done an exceptional job in continuing the astronaut training, and it's no trivial thing to organize this, and they've done a great job. So.
So I just want to thank our entire panel for agreeing to do this. Again, it's one of the great things about Survey is trying to engage everybody out there and get everyone excited. And as Jack iterated over and over up here, it's the young folks who really carry the torch and can get the work done when the hard times come up. So I'm glad to see so many people here. And again, thank you all for being here. And I guess I'd just kind of like to have maybe everybody stand up and give an ovation for your colleagues, Ronald